Hello, I'm going to be demonstrating the operation of the HB500 balancing machine. So first I'm going to turn it on with the main power switch here. The lights turn on, the screen turns on, and while that's turning on, we're actually going to work with the mechanical side first. So here we have the part that's already in the balancing machine. So the way we would normally load it, I'm not going to show hoisting it in, but you can put this in. Right on the screen here is the belt idler, and we're going to turn the belt idler off. So normally the belt would be draped like this on the balancing machine. So we put the part in, and we drape the belt around. Part here, thread the belt around the pulleys like this. Once they are in place, then I'm going to hit the belt idler switch from off to on. And now the belt is running. So this is the way that the belt is supposed to be threaded through these pulleys here. If you need to make an adjustment to the height of the balancing pedestals so that the part is level, you would do that, and I am going to demonstrate how that works. So I would put the level here, and I can loosen the carriage screws, carriage locking screws here. So now I need to lower this side. So I'm going to take this handle here and start to lower that until the bubble level is in the center. So now we've centered, or leveled the part rather. Always remember to tighten the carriage locking lever handles here. This has to be tight as it fits in here. Some other adjustments that will be need to make for different balance setups, and that is the end stops. So the end stops have a series of blocks with set screws on each end of the block, and you can move your end stop thrust bearing here in any direction. So, but normally we would put the end stop bearing at the 6 o'clock position on the bottom of the center of the part. So when the part rotates, it's going to run against that bearing and keep the part from falling off of the bearings. So I can do that on both sides. Now, one thing to make note that we actually want the rotor to be able to float a little bit left and right. So we would normally put we don't want these touching both rollers. We want to just back one of them off approximately a 1/16 to an 1/8 of an inch off, and then we tighten that down with this set screw, and this allows the part, as it spins, to freely go one side or the other. Sometimes you will notice that a part will migrate either left or right, and that's okay as long as it's free to migrate either left or right without it being constricted. The next thing we're going to do is adjust the photo sensor. Now I have a piece of masking tape, and we put a black line with a normal Sharpie will work fine. We make that line approximately 1/4 inch wide, and so we're going to be targeting with that black line on our photo sensor. This black line represents our 0 degrees, or our top dead center 0 degree mark. From everything is going to be measured from that. And so if you can see that there is a white light that shines out of this sensor, I'm shining this in the back position here. Okay, I can bring that back here, and I'm going to show you what we do. So I put the light approximately, it's usually between 1 to 2 inches. Sometimes you can even go a little bit farther, 3 inches. I normally will say 2 to 3 finger widths is the optimal distance. Makes it a lot easier. You don't actually have to measure it that way. So I bring my light to my white surface, and I press the white button for 3 seconds, and this will automatically calibrate. 1, 2, 3. You may have noticed that the green LEDs shot from 1 up to 5. This sensor is self-learning, so it will learn how much light it needs until it reflects. And then, if all is well, when it hits the black line, it's going to trigger. So you see that output trigger? So that's what I want to see. I want to see 1 output pulse per revolution. That's critical that we have just 1 pulse per revolution, and because that's our start of our measurement, and everything is going to be calibrated off of that. If when you are moving your carriages around or you have a different part, you need to move either the motor base, left pedestal or right pedestal, you can move these lever arms, move this left or right, but make sure you tighten them back down. You don't have to be super hard tight, just tighten like that and that'll be fine. That is the physical setup that we have here. I would like to just show that the guarding is on rails here, and this is meant to close and engage. Once this engages and we're ready to go, the green light on the start button will say, I'm active and ready to go. Doesn't mean it's going to automatically start, it's just saying it's ready to start. So when I pull this open, now you cannot start the balancer. So this has to be closed and the green light has to be on. Also, the same thing with the belt idler. If the belt idler is not on, this will never turn green. You can't spin the motor without having the belt idler on and engaged and ready to go. If you need to turn the machine off very quickly, hit the e-stop button, and that will stop all motion. Now we're going to demonstrate how we set up the balancing computer. When you turn the balancing machine on, the balancing software is automatic and it will come up to whatever part we have done last. In this case here, I'm going to use my arrow to show that we did part number 5,000, what we call 5,000. That was our last setup. But this is how we create a new setup. I can go to the shortcut icons with a new blank page, or I can click File, New, and a new balancing program will come up. The next step is press Edit Part button, and now all of our part parameters are shown on one screen here. So I'm going to start with some basic things here. We can choose between ounces and inches, ounce, millimeters, centimeters, gram, inches, whatever. So I'm going to actually use gram, inches, and I'm going to, the next thing is our part setup. This is not a static couple setup, this is actually a two-plane setup. And when I show a two-plane setup, then you can see this is now the rotor diagram that we're going to be using. So we are going to have to measure the A dimension, the B dimension, and the C dimension. The A dimension is the dimension from the center of the left bearing to where we're going to be adding weight in the left plane. The B dimension is the center of the right bearing to where we're going to be correcting on our right plane. And the C dimension is the distance of center of the bearing to center of the bearing. And that's going to be over here on the screen shown A, B, and C. If there are fields that are dim and you can't make any changes, that's because that setup parameter is not active for this particular setup. So let's do that right now. I'm going to open up the door and I'm going to measure. I'm going to take my tape measure and measure from where we're going to make your balance corrections, which look like right there, to the center of the bearing, and that looks like it is essentially it's 1 inch. So my A dimension is 1 inch. So I'm going to take my mouse and I'm going to swipe and just type 1.0. To get to the next screen, don't press enter, rather press tab. Or you can use your finger or a pointer or the mouse. This is a touch screen, so you can actually use a touch screen. Let's measure our B dimension. The B dimension is actually from the inside to that center of that bearing there, and that looks like it is also 1 inch. And while we're at it, we're going to measure the C dimension right here. So I'm going to measure from the center of the left bearing to the center of the right bearing, and that is at 19 3/4 of an inch. So back to our computer here. Our dimension B is set 1.0. Press tab. We had 19.75 was our C dimension. Part correction radius. So this is how far out from the center we're going to be adding our weights. So in the left balancing plane, that dimension is approximately 2.75 inches. So I'm going to use my fingers to show you that you can use a touch screen, and the keyboard 2.75. Press tab. Our plane B, which is our right correction, let's measure that radius. And that is, we're going to call that 3 inches. 3.0. The next item on our list is the plane A and plane B tolerance. And for now, I'm going to leave the tolerance, I believe it was at 3 grams for the left and 3 grams for the right. And our tolerance units is going to be actually grams. This part does not use segments, which is a feature for fan blades. The next thing that we have to change is the plane A, add or remove. So we're going to set this to add weight. We want the balancer to tell us where to add weight for left and right. Tooling compensation is nothing that we need to use. That's when we have a balancing arbor. Manual measurement run is a feature that is used when we want to take multiple measurements with the same run, but we have everything done automatically here. And I'm going to use a run time. I'm going to just make that 6 seconds, which should be an adequate amount of time. That's how long the sample period will be for measuring. Once I'm done with that, I press the save button, and then the dialog will come up, and I can call it whatever part number. I'm just going to call this part number 1 for the sake of our demonstration here. I'm going to click save. So now we have saved part number 1 with the parameters that we saw in edit part. Before we can run the part, we need to first do a calibrate angle sensor. This is done the very first time after calibrating the photo sensor back on the machine here. So we need to teach the balancing machine where this photo sensor is relative to the unbalanced signal. So it's done like this. If we look back at the screen, the on-screen instructions say, place the calibration test weight on the part at 0 degrees, start motor when ready. So I'm going to take a piece of modeling clay that we include, and a chunk of that size is adequate. I'm going to put this directly into the left plane just because it's easier, and exactly of the mass center is at that 0 degree line. So this is going to tell the machine where our 0 degree mark is. So with the weight in the part, I close the door, and I press the start button. The balancing machine will come up to speed if you see the RPM. Once the RPM is stable, it automatically takes the measurement for 6 seconds, and then it will stop automatically. Once everything is at completely off, we can open the guard door, and now the screen says, remove the calibration test weight from the part. So I take the test weight out, close the guard door, press start again. So now the balance computer will measure the before and after results, and from that it will know where that photo sensor is relative to the unbalanced sensor. And we give a little bit of feedback just so you kind of know when something is happening, but it's important to press yes. So I'm going to click yes. It's going to save that value. So that angle calibration is now permanently saved with part number 1. At this point, these balance readings here are ready to go. So I'm going to press start. After our 6-second run time, we're going to get an amount on the screen. So it's asking for 9.8 grams at 102, 20 grams at 217. So where are those angles? This 102 degrees and 217. So we have this encoder reading, which is in red, which automatically tracks as I rotate the part. So when I bring my black line to top dead center, it should show 0 on the balance screen, which it does. So to go to 102 degrees on the left, I rotate this in the same clockwise rotation until the screen says 102. At this point, top dead center on the left is 102 degrees. Here's where I would add my 9.8 grams, right there. And I'm going to just put a small weight at that location. Now if you go back to the screen, on the right balance plane, it says 217 degrees. I'm going to rotate that until 217 degrees shows up on the red number. Now on the right balance plane, top dead center, this is where we need to add grams. I'm going to add a weight up in here as well. Once your weights are added, close the guard door, press start, and we should see a reduction in the unbalance reading. And we do. I didn't put enough on, but I just wanted to show you this is how it works. And at this point, you would continue to add the appropriate amount of grams until the part is balanced. Once it's below the balancing tolerance, it will say pass and pass.